Alright guys, in this video I'm going to show us how to solve a system of three linear equations, right? Three equations, but this time we have three variables, right? So we have x, y, and z this time, whereas when we're solving a system of two equations, we had just x and y. So there's a little bit more involved in this one, although the technique is the same as for two equations. It is going to be all about canceling variables, such that ultimately it boils down to one equation with one unknown. So right now we have three equations with three unknowns. We're going to get it down to two equations with two unknowns, and then from there to one equation with one unknown, and therefore we're going to solve that equation. All right, so just like before, what we're going to do is we're going to manipulate these equations such that one of the variables cancel. You can choose any variable you like, it really doesn't matter. I'm going to choose for convenience to cancel the x variable, and I'm going to choose two of these equations from the three that are up there. I'm going to choose equation number 1 and 2, just for convenience. So, if I were to cancel, say, the x's, if I wanted to do that, well, notice here I have 1x in my equation number 2, and in equation number 1, and equation number 2 I have 4x. And so, in order for those to cancel, I want this x here to be also 4x, which means I'm going to, or minus 4x, that would also work. So in order to make this 4x, I'm going to multiply this equation here by 4. So this equation will become 4x plus 4y minus 4z is equal to minus 1. And therefore, once I have 4x here and I have 4x in equation number 2, I can simply subtract equation number 2 from that equation. So to write it out, what I'm going to do is I'm going to take 4 times equation number 1, and I'm going to subtract equation number 2. That's what I'm going to do. That's going to be my methodology. So, 4 times equation number 1 is 4x plus 4y minus 4z is equal to minus 4. Subtracting, parentheses, equation number 2. Equation number 2 is 4x minus 3y, let's just write that first, plus 2z is equal to 16. Like I say, now I'm just going to subtract one from the other, and my x's will cancel. 4x minus 4x is 0x, of course, that's my intention. 4y minus 3y, minus times minus is a plus, so 4 plus 3 is 7y. Minus 4z minus 2z is minus 6z. You gotta be really careful with your arithmetic. Minus 4 minus 16 is minus 20. All right, so I now have, having canceled that x term, I now have one equation with two unknowns. So I still can't solve it. One equation with two unknowns can't yet be solved. So I need to find two more of these equations, and again cancel that x term. The reason it's important that I can again cancel the same variable, in this case x, is so that when I do that cancellation, I'm going to end up with an equation in y and z again. All right, so what I'm going to do is I'm going to choose equation number 1 and 3. I'm going to choose those two together. Let me just get rid of this right here. Here I have a 2x, and here I have an x. So obviously it makes sense for me to multiply this equation now by 2. Right? So I'm going to multiply this here equation by 2. And what I will do is I will take 2 times equation number 1, and from that, which will give me 2x plus 2y minus 2z is equal to minus 2, and from that I will subtract equation number 3. 2 times equation number 1 minus equation number 3. Okay, let me just put that up here. We have a little bit more board space. All right, so 2 times equation number 1 is 2x plus 2y minus 2z is equal to minus 2. And I'm going to subtract, I'm just going to move this line over a little bit so I have more room. From that, I'm going to subtract 2x. Equation number 3, 2x minus 2y minus 3z is equal to 5. Right? So subtract this equation from this one. 2x minus 2x will of course give me 0x. Again, that's what I'm setting out to do, that's my intention. 2y minus 2y. A minus times a minus is a plus, so that's plus 4y. Minus 2z, minus times a minus is a plus, so that's minus 2z plus 3z. So that is plus z. And then finally, I have minus 2 minus 5, that is minus 7. Just be careful with your arithmetic. So, I now have here an equation in y and z, and I have here an equation in y and z. And so I can now go about manipulating these by multiplying one or the other or both in such a way that one of my variables will cancel. It would be easiest for me, here I have a negative 6z, and in this equation here I have a plus z. So if I were to multiply this equation here by 6, I would get a 6z term. And therefore, if I were, and because I have a negative 6z here, this 6z term, were it added to this negative 6z, would cancel my z. So that's what I'm going to do. I'm going to take this equation, and I'm going to multiply it by 6. So 6 times 4 is 24, that's 24y. 6 times z is plus 6z is equal to 6 sevenths or 42, so that's negative 42. Now I take this equation right here, and I put underneath 7y minus 6z is equal to negative 20. And rather than subtract them, as I've done previously in order to get one of the variables to cancel, I will add them, because I have here a 6z and here a negative 6z. So if I simply add these two equations together, I should get the result I want. 24y plus 7y is 31y. 31y. 6z plus negative 6z will cancel. And minus 42 minus 20, if I'm not mistaken, that is minus 62. And so I have that 31y is equal to negative 62. What have I got? I have got one equation with one unknown. And so this is what I really want, because now I can solve for that unknown. And so therefore, if I divide both sides by 31, I get that y is negative 62 over 31, which is negative 2. Negative over a positive is, of course, a negative. And so I have worked out my y value. My y value is negative 2. In order to work out my x and z values, I can just simply substitute back in my y value into my equations. It would be, the first thing you're going to want to do is substitute in your y value into one of your equations that is just y and z. So we can, let me just erase a little bit of this. I'm just going to take this off the board. So I have some space. These are my original equations. I'm going to hang on to those. I'm going to take this equation right here, 4y plus z is equal to negative 7. And I can substitute in my y value of negative 2 in here. And so this will become 4 times negative 2 plus z is equal to negative 7. That's negative 8 plus z is equal to negative 7. And so therefore, adding 8 to both sides, I will get that z is equal to negative 7 plus 8, which is 1. And so I get that z is equal to 1. Okay, and so therefore, I'm almost there. I've got my y value. My y value is negative 2. My z value is 1. And so it just remains to find my x value. So I can just substitute my values for y and x back into one of my original 3 equations. Probably equation number 1 looks like it would be the most straightforward. So let me just erase this. Need somewhere to write. there. And so I'm going to take equation number 1 and I'm going to substitute in my values of y and z. That gives me x plus, my y value is minus 2, minus, my z value is 1, is equal to minus 1. And so therefore, that is x minus 2 minus 1 is equal to minus 1. Therefore, x minus 2 minus 1 is minus 3. And therefore, adding 3 to both sides, I get x is equal to minus 1 plus 3, which is 2. And so I get that x is equal to 2. And that's my value for my x. And so I have solved my entire system of equations. I have found the value of x, the value of y, and the value of z that satisfies all 3 of these equations. And if you wanted to check, all you would do is you would take this value of x, this value of y, this value of z, and you would substitute it into this equation, substitute it into this equation, and substitute it into this equation. You do all 3, and you would see that all 3 equations would be satisfied by these 3 values that we have found. And so that's it. Like I say, it's a little bit more involved than the system of 2 equations, but ultimately the methodology is the same. And of course, if we had a system of 10 equations, we would need a system of 10 unknowns, and we could go through the same method, and we could cancel until we get down to one equation with one unknown like we have here, and then we can solve it, and we can just substitute back in. That is how we go about solving these systems of equations. All right, thanks a lot.